Welcome to the AI Research Roundup. I am your host, Alex. Today is May 12th, 2025. We're diving into an interesting ICLR conference paper published just over 3 months ago on January 22nd, titled More RLHF, More Trust, on the Impact of Preference Alignment on Trustworthiness. This paper investigates a really critical question. Does reinforcement learning from human feedback, or RLHF, which is a widely used technique to align LLMs with human preferences, actually make these models more trustworthy? And by trustworthy, we're talking about aspects like safety, reliability, and ethical alignment. The core finding here is that using general-purpose preference data for this alignment doesn't automatically guarantee better trustworthiness, and can sometimes even be detrimental. Alright, so this first figure we're looking at, Figure 1, really lays out the reinforcement learning from human feedback framework they used. It starts with data from the Anthropic HH dataset, which provides a prompt, a chosen preferred response, and a rejected one. The model first undergoes supervised fine-tuning, or SFT. That's a stage where it learns to mimic these preferred responses. Then, a reward model is trained to assign higher scores to preferred responses over rejected ones. Finally, algorithms like proximal policy optimization, or PPO, and direct preference optimization, or DPO, use this reward signal or direct preference data to further align the model before its trustworthiness is evaluated. Okay, so building on that reinforcement learning from human feedback framework, Figure 2 here shows some really interesting results from the evaluations. We're looking at 2 key trustworthiness aspects. On the left, there's expected maximum toxicity. Essentially, this measures how likely the model is to say something harmful, and lower scores are better. And on the right, we see the stereotypical bias agreeability index, which gauges the model's tendency to agree with stereotypes. Again, lower is better. Across various models, toxicity doesn't change much after supervised fine-tuning, or the subsequent proximal policy optimization and direct preference optimization steps. But look at bias. It actually gets significantly worse, especially after supervised fine-tuning. Now, turning to Figure 4, we see a deeper dive into other trustworthiness dimensions. The bar chart on the left tracks private information leakage percentage, essentially how often the model might reveal sensitive data. Across all models, both the proximal policy optimization and direct preference optimization steps tend to increase this leakage. The table on the right then gives a broader summary. While machine ethics, the model's ability to make ethically sound judgments, does improve, truthfulness, its accuracy in providing facts, and privacy both get worse after these alignment steps, echoing the negative impact on bias we saw earlier. Alright, so Figure 3 gives us a closer visual on 2 of those aspects we just touched on from the summary, machine ethics and truthfulness, confirming what was suggested. On the left, we see the false negative rate on ethics statements. That's how often the model fails to flag something unethical, so lower scores are better here. And generally, both proximal policy optimization and direct preference optimization improve this ethical judgment. But on the right, looking at accuracy in choosing the ground truth, which is its ability to pick the correct factual answer, that tends to dip after these alignment steps, especially after supervised fine-tuning, reinforcing the drop in truthfulness. Okay, so we've seen these varied impacts on trustworthiness. Figure 5 now tries to shed light on why, by showing overall contribution scores. These scores come from influence function-based data attribution methods. Essentially, these are clever ways to estimate how much the training data used in each alignment step actually pushed the model's performance on these 5 trustworthiness aspects, like toxicity or bias. A higher score means the data had a bigger hand in the changes we observed. For example, for the Pythia 6.9b model, after supervised fine-tuning, the data had a notably high contribution to stereotypical bias, which, if you recall, got much worse. So, building on those overall contribution scores, Figure 6 now zooms in on specific examples of the fine-tuning data used. For each trustworthiness aspect, like toxicity or bias, we see actual text snippets from the training data, alongside bar charts showing the individual contribution scores from supervised fine-tuning, proximal policy optimization, and direct preference optimization. What's really telling here is how a single piece of data can push the model in a negative direction, even if the overall alignment step generally improved that trustworthiness aspect, as seen with the ethics example here. So, seeing how even individual data points can sway the model, the overall picture from this research becomes clearer. It really highlights that using reinforcement learning from human feedback, a method where models essentially learn by getting feedback on their responses from humans, especially with general-purpose preference data, isn't a guaranteed path to a broadly trustworthy model. While machine ethics saw improvements, other crucial aspects like stereotypical bias, truthfulness, and privacy unfortunately worsened. This underscores the critical need for more nuanced alignment strategies. That's all for this AI Research Roundup. Thanks for tuning in.